All right, welcome to 5.3. Then we're talking 5.3. We're doing isosceles and equilateral triangles. So an isosceles, if you remember, is a triangle with two congruent sides. When they have two congruent sides, we call those the legs. So that means here, AB and BC are our legs. The angle where our legs intersect is called the vertex angle. So here, angle B is our vertex angle. The side opposite of our vertex angle is called our base. So that's AC right here. The angles along those bases is called our base angle. So that means angle A and angle C are our base angles. Now we have a couple theorems associated with our isosceles triangle. We have the isosceles triangle theorem, which states that if my two sides, my two legs are equal, then my two base angles are equal. So again, if AB is equal to BC, we see that over here in our, so AB is equal to BC, then A is equal to C. We also have the converse of that. Remember, we're just switching our if and then with our converses. So, if our two base angles are equal, then the legs associated with those base angles are also equal. All right, now we're going to use that to our advantage here. So, for example, number 1 here, our two legs are congruent, which means our two base angles are also congruent. That means angle J is also 68 degrees. To find angle K, we are going to just subtract that from 180, and that gives us 44. Here we are given our vertex angle with our two legs being congruent. So that means this angle and this angle are equal. I'm going to call those x's. So that means x plus 106 equals 180. So that will give me 2x equals 74. When I divide that, that'll give me 37 to each side. Perfect. Here, my two base angles are equal, which means my two legs are equal. That means YZ is also 12. And again, we can use that triangle angle theorem. 77 plus 77. Subtract that from 180. That gives me 26 degrees. All right, let's look at number 4 here. So once again, I know my two legs are congruent, which means my two base angles are equal. So I'm going to set up my equation as 5x plus 9 is equal to 8x minus 30. I'm going to subtract that 5x over, so that'll give me 9 equals 4x minus 30. Add that 30 over, so that gives me 39 equals 3x. That should be a 3 right there. There we go. Okay, divide both sides by 3, so x equals 13. 5, you're doing the exact same thing. 6, now it's saying my base angles are equal, which will tell me that my two legs are equal. So I'm going to do 5x plus 7 equals 23x minus 17. Going to move my x's over, so that will give me 24 equals 8x. It should be a 15 there. There we go. Okay, divide both sides, so I get x equals 3. There's 7. You can go ahead and pause the video if you'd like to write that one down. Again, my two base angles are equal, thus my two sides are equal. All right, so for 8, we are going to make our triangle. All right, so there's my perfect triangle. I know that R Whoop. There we go. R, S, and T. Doesn't matter where you label them. It's telling me that RT is the same length as ST. They're telling me angle R is 9x plus 2. They're telling me angle S is 13x minus 18. And they're informing me that angle T is 17x plus 1. So because my two legs are equal, that means my two base angles are equal. So I'm going to set that up as 13x minus 18 is equal to 9x plus 2. Okay, when I solve that, I'm going to move my x's over. So that gives me 20 equals 4x. Divide by 4. So I get x equals 5. Now I have to take that 5 and plug it in everywhere I see an x. So that means R is going to be 47. We said our two base angles were equal, which means S is also 47. And T is going to be 86. All right, there's 9. Feel free to pause the video. And 10. All right, let's talk equilateral triangles. Equilateral triangles mean if all of our angles are equal, then all of our sides are equal. And again, we can do the same thing. If all of our sides are equal, then all of our angles are equal. Again, we hinted at this when we were talking about equilateral and equiangular. If it's equilateral, then it's equiangular. And you can do the opposite. If it's equiangular, then it's equilateral. All right. So let's talk about this one. Now, the nice part about these triangles is that no matter what, your angles are always 60. That's because they're all equal. So 180 divided by 3 is going to give you 60. We know that this side is 9, which means all of my sides are 9. Next, we're going to talk about 12. So like I said, all of my sides are going to be 24. And with an equilateral triangle, all my angles are 60. So that means that's going to be 60. That's going to be 60. And that is also going to be 60. All right, looking at 13 here, we have triangle PQR. And again, it is an equilateral triangle. So we're going to solve for our x's and our y's here. Well, like I said, all of my angles are going to be 60. So to solve for my x's, I'm going to do 7x minus 3 equals 60. Add 3 to both sides, so I have 7x equals 63. Divide by 7, so I have x equals 9. We're going to do the same thing for y. I can do any of my sides as equal. So I'm going to do 11y minus 23 is equal to 9y plus 1. Again, you can do any of those sides because they're all the same. So I'm going to minus my 9y over, so that gets me 2y equals 24. Divide both sides by 2, so y equals 12. All right, guys, that concludes today's notes. If you have any questions, let's get together and let's talk it out. Have a great day and do the assignment listed above.